Good morning, grade 10. We are doing problem 6 from Maths 2 set 1.3. Now the problem says that in trapezium ABCD, you can see ABCD. In trapezium ABCD, AB is parallel to DC. AB is parallel to CD or DC. Diagonal AC and BD intersect at point O. You can see this is point O where two diagonals intersect. If AB is 20, AB is 20, CD is 6, OB is 15, then you have to find OD. This problem is very much similar to problem number 5 if you remember. Now see, once you know that CD is parallel to AB and considering BD or DB as a transversal, we can tell that angle CDB is congruent to angle DBA because this is forming Z. Can you see? These two are parallel lines and this is transversal. So these two are alternate angles. If lines are parallel, alternate angles are congruent. Now you have relation D dash O dash B. So angle CDB is similar to angle CDO. Similarly, angle ABD is similar to angle ABO. Only this is extension of the ray we have seen earlier also. And now if we consider this small triangle 1 and below which is triangle 2. If I consider this as first triangle and this is second triangle, then in these two triangles I have written over here CDO is congruent to ABO. CDO is congruent to ABO. We have seen from the first, I have written here from first, this step. Now this angle, can you see? These two are vertically opposite angles and we know vertically opposite angles are always congruent. So which is this angle? COD, or you can call it as DOC is congruent to angle AOB. Now so in these two triangles, two angles are congruent of each triangle and therefore these two triangles are similar by AA test of similarity. You know that once the triangles are similar, their sides, corresponding sides are in proportion. Now students have problem in writing how to write the sides. Now see what I have written, OD upon OB. Concentrate on OD and concentrate on OB. Which is the angle opposite to OD? Opposite to OD is angle C over here, which I have shown by small circle. So look over here, small circle, it is this. So opposite to this will be OD. So if you are taking of this triangle, side OD, of this triangle you should be taking side OB. So OD upon OB is equal to, now I have taken DC because first I have considered small triangle. CD is opposite to this angle. Vertically opposite angle is this. So opposite to this will be BA. And so I have written DC upon AB. Have you understood how to write? So look at the angles. Which angles are congruent? Sides opposite to that will be in the proportion, so that you will not go wrong. Now just substitute the values. OD is X we have taken. We have to find it out. So OD upon 15 is 6 upon 20. So OD which is equal to X I will write over here because we have mentioned that in the figure. So X is equal to 6. Just cross multiply. 15 into 6 upon 20. So 5 3s are 5 4s are 2 2s are and 2 3s are. So we have 9 upon 2 which is equal to 4.5. I hope it was easy. Okay. This is your 7th problem, students. Given is that A, B, C and D. This is a parallelogram and we have to prove DE into BE is equal to CE into TE. Now see here, if ABCD is a parallelogram, we know that opposite sides of parallelogram are parallel. So what can we write? AB is parallel to DC. Alright. Okay. So just now what we have seen, AB is parallel to DC, but AB can be extended as AT. So we can say AT is parallel to DC because of A dash, B dash, T. These three points are collinear, you can see, alright. So AB is similar to AT. This line is just extended. Now if we consider these two parallel lines and if you consider DT as a transversal, you can see this Z. Look at this Z where I have marked these two angles. So these two become alternate angles And as per alternate angle property, if lines are parallel, alternate angles are congruent. So we have ATD angle is equal to TDC. But very carefully observe that ATD, I can also write it as BTE, because these two are extensions of the line. Alright, so similarly, TDC can be written as EDC. I have written all the steps over here. You may pause the video and take down the steps. See, just now what I said is over here. BTE, this angle is equal to or congruent to CDE. Now we consider these two triangles. Can you see? So which triangles we are considering? DET and BET. This is first triangle and this is another triangle. You can see. Triangle CED. In these two triangles we have just now seen that they are congruent. And these two which I have shown by small circle, these are vertically opposite angles. So these two triangles, they become similar by AA test of similarity. Now you know that once the triangles are similar, over here I have written AA test of similarity. Once the triangles are similar, sides are in proportion. But you see what has been asked. We have to prove that DE into BE is CE into TE. That means while writing the sides in proportion, we should be considering DE side. DE, that means this side, and BE, this side. So these two sides and CE and TE. So two proportions we have to write using these two sides. So see now what I have written. Once the triangles are similar, BE upon CE. Where is BE? Just check BE. It is opposite to this angle. Now this angle is congruent to angle D over here. Opposite to this will be CE or EC. So I have written BE upon CE is equal to TE upon DE. Now see where TE is opposite to this third angle B. Over here this angle will be equal to this, which I have not marked with anything. Opposite to this will be side DE. So I have written TE upon DE. Please be very careful when you write the proportions. Always concentrate on the angles and then write the side opposite to congruent angles one above the other. Then you get the correct proportion. Once you get, you just cross multiply and check what we get. This will be multiplied over here and this will be over here. So we get BE into DE is equal to CE into TE, and that is what we have to prove. So it is that easy. Alright, I hope it is clear. Only thing is this part. You should be very crucial as to how to write the proportions and which sides we have to choose looking at what is to be proved. Alright, okay. Here is your 8th and 9th question. These are the most easiest problems in this set. Now see students, they have already given that AP upon CP is equal to BP upon DP. In these two triangles if you compare, AP upon CP is exactly equal to BP upon DP. They have given these two sides are already in the proportion. It is given. And can you see this P angle of both the triangles, vertically opposite angle? Which angle I am talking about? Angle APB, this. And angle CPD, this. These two are vertically opposite angles. So obviously by SAS test, these two triangles become similar. There is nothing, direct test is given. Now going to the 9th question, just see now. Given is that angle BAC, this big angle if you can see, is equal to angle ADC, this angle. Now angles of equal measures are congruent. So we can also say BAC is congruent to angle ADC. What we have to prove? CA square is equal to CD into CD. Now carefully observe. If I consider this big triangle ABC and this small triangle ADC, I have one angle which is already given as congruent, that is angle A and D. Over here I have written A and angle D. It is already given. And in both these triangles, angle C is common, you can see. Angle C is common to both the triangles, isn't it? So for ABC it will be angle ACB. And for the smaller triangle it will be angle ACD. So ACB and ACD or DCA. This is common angle. So if two angles are congruent, then two triangles become similar. By which test? AA test of similarity. So again we got triangle ABC is congruent to triangle ADC by AA test of similarity. Now once the triangles are similar, their corresponding sides are in proportion. Now while writing this, be careful what is asked. What is asked? CA square. That means I should be getting CA twice. Isn't it? CA is common side for both the triangles, you can see. So what I am writing, the ratio C, CA upon CD. Look, CA upon CD. That means this CA is of bigger triangle. CA or AC you can say. CA is opposite to angle B. This triangle angle which is not marked at all. And opposite to this angle is which angle over here? This small angle over here. So opposite to this will be what? CD. You can understand what I am saying. See, this angle of bigger triangle is similar to this angle of smaller triangle. Opposite to this is what? AC. Opposite to this is what? DC. So I have written CA upon CD. Alright. Is equal to CB upon CA. Again. Now see CB. CB is where, just check. CB. Bigger triangle. It is opposite to this. Now this angle is similar to this. So for this opposite side is again AC. Alright. So I have written CB upon AC or CA. Both are same. Now you just cross multiply. What we get? CA into CA will be CA square, which is equal to CD into CB. So the main thing is proving the triangles similar and then writing the sides in proportion. Look at the what is asked. To prove is what you see, and accordingly that you write the sides in proportion. Doesn't matter if you write all the three sides. And for writing the sides in proportion, what I have told you, concentrate on which angles are congruent. Write the sides opposite to the congruent angles. Then you will never go wrong. I think this is the end of your set 1.3. That's all for today, students. Thank you.